Hello Internet, my name is Quentin and this is Blondihacks. I'm working on my locomotive this week. We're going to make the smokebox door. That's the great big chunk of metal that covers the entire front of the smokebox and really gives the locomotive its face, if you will. It's a very important cosmetic and functional part, and we're going to get started on it right now. Up here on the front of the giant Duracell is where the smokebox door goes. It's going to be one massive chunk of brass that forms this entire assembly. And I do mean massive. This thing is 4 inches in diameter. On real locomotives, of course, and on most models, the smokebox is a frame with a door in the center of it that opens for access to cleaning the smoke tubes and other various maintenance jobs that happen inside the smokebox. However, Kozo's model doesn't have that. It has one giant piece. The door is actually fake, and you remove the entire thing to access the inside of it. I think that's perfectly fine as a simplification to make this model easier to build. An opening door in this case would be frankly too small to be useful anyway, and requires 6 bolted clamps to be removed to open it, just like on the real A3, rather than just 2 bolts to take the entire thing off on the model. This does pose an interesting materials challenge, however. This is a giant solid brass disc, and a giant solid brass disc can be pretty spendy. If you set out to go and buy, say, 4-inch brass round bar to make this from, you're going to find out 4-inch brass round bar is a lot of loonies. This is because when you buy metal, you're paying by the atom, and the shortest length that you can get in this diameter is a very large volume of brass. However, there's a trick we can do because we only need a 1/2-inch thick piece of round bar. If you go and look at the 1/2-inch flat bar, you'll find that it's a whole lot cheaper. So it's much cheaper to make the disc we need than it is to buy it and make it from round bar. Of course, if I had panned my eyes down slightly while looking at these options, I would have seen that McMaster also offers 4-inch round bar in 1/2-inch thick disc stock. Disc stock is great for this type of situation. Manufacturers have acknowledged that buying giant pieces of round bar is usually ludicrous because you don't generally need that much of it. You're generally making discs. You've seen me do this for other parts on this channel, large cast iron backing plates, that sort of thing. So why didn't I do that this time? I'm glad you asked. Thanks for bringing that question. There's a very, very important reason that we really need to discuss here. It's because shut up, that's why. Look, I didn't see it, okay? So I did it this other way. I'm dumb, I know. Look, it was even $20 cheaper. Jeez. Moving right along, I'm going to go ahead and cut a 4-inch square out of this piece of flat bar, and that will be the proto disc. 6 inches is the shortest length they would sell me, but that's okay. I've got a very nice chunk of flat bar left over there, and that'll become something else someday, I'm sure. Now we'll mark the center of this, give that a little punchy punch, and trace the outline of the disc that we're going to want to create. This is oversized so that we have room to turn it down. Then over to the bandsaw, and I'll lop off the corners reasonably close to my layout line there. Saves a lot of turning time to do this. All right, speaking of turning, let's get started on that. I'm going to start working on the back side of the part first, and I'm going to make sure it's sitting flat in the chuck because I want to do as little material removal as I can to clean it up. I have very little extra material thickness. I can't afford to get crazy with making chips. Then I'll dial in my center punch mark to make sure that my circle is going to fit in the rough material that we have. That's looking good. Now I'll face the front of this to make it nice and flat. And again, I'm taking off as little as I can. As you saw in a minute ago, this indicated in less than 1/1000th all the way across the 4-inch part, which is excellent. The flatness of the factory surface was actually very, very good in this case. It's always nice. When that happens, it means I can take a very light cut and it'll clean up, and we've lost essentially no nominal thickness on the material. Now I can turn the OD for the rear section of the part. Obviously I can't access all of it because it's in the jaws, but the back of this smokebox door has a shoulder on it that seats into the smokebox. And the material is thick enough, or rather I guess my jaws are shallow enough that I can cut the entire outside of this shoulder in this setup without touching the jaws. It is close, mind you, but we can do it. If I'd needed to, I could have put some packing material behind this as well to push the disc outward a little bit to give me the clearance to do this, but no big deal. A little bit of a turny-turn until I get that shoulder the correct diameter. Had to get out my largest micrometer for this one. These are big girl parts. That's measuring correctly, so this should fit. I'll do a check on the actual smoke box. And survey says, well, it's very close, like it wants to go on, but the smoke box has gotten a little bit out of round. After that last bunch of silver soldering we did, getting all of those little brackets and mounting bosses and stuff in there, it has developed some flat spots. Silver soldering does not pull or distort the material inherently the way that welding does. However, you're heating it past the plastic point of the material, and so just the weight of the material or the setup can cause it to deform just from being so hot. I took measurements all the way around and located the flat spots. I used a combination of tapping and some machinist jacks to press it back into roundness. Once it was close, then I knew I could actually just use the smokebox door itself as a hammer form, as it were, and get the last little bit of roundness back into it. A little percussive persuasion, and that is now a perfect fit on there. Excellent. Once it's been tapped on once, then it goes on easily after that because the first tapping operation made it round again, essentially. It's a nice thing about copper. It's easy to persuade in that way. All right, now while I'm here in this setup, I'll put a threaded hole right through the middle of this thing, and this is going to hold the number plate that goes on the front of the smokebox door. This is also going to be useful for fixturing, which is why I want to do this now. At this point, I'm done with this setup in the lathe, and the drawings recommend flipping it over and holding it by that shoulder to do the features on the other side. However, I don't really like that idea. You can see there's not a lot of material to hang on to there, and I have to pull it out of the jaws a little bit so that I can turn the entire remaining diameter without touching the jaws, which gives me even less to hang on to. So not a huge fan of this. I'm going to do this a different way instead. I'm going to take it over to the mill, and you'll see why in a second. The drawing calls for a 3-hole pattern of threaded holes on the back of this thing, and I'm going to dial it in on the mill and put those threaded holes in now. These holes are for mounting a counterweight inside the smoke box, because when a locomotive is pulling a heavy load, the drawbar, of course, tends to pull the back of the locomotive down under the load, and the front end of the locomotive comes up, and that causes you to lose traction on the front drivers and lowers the tractive effort of the locomotive. So if you put a big heavy weight in the front, it counteracts that and also just adds a bunch of weight to the locomotive, which is always a good thing in locomotives. More weight equals more tractive effort. So that counterweight, however, is not going to be installed for a long time yet. However, these holes are going to be very useful for fixturing, as you'll see. So I'm going to use them for that purpose. I dug through my scrap bin and I found this nice disc of aluminum that actually already has a machined OD and one face. That's perfect. It's going to save me some effort. I'll chuck this up in the forejaw, dial that in so that the OD is going to be concentric with the fixture that I'm going to make this into. I'm going to start by facing this flat, and then once I've got this flat and thus have two parallel faces, I can then take a boring bar and I'm going to machine out a pocket that's going to hold that shoulder on the back of the smokebox door. I've still got one low spot there, but I'm going to leave that. I don't want to take off too much material here because it's getting pretty thin already. I don't have a ton to spare, and I want to use this piece of scrap. So here's that pocket I was talking about. I'll machine that out to be a close fit on the smokebox door. And that's important because I'm going to be using the outside of this fixture as a concentricity reference in a number of setups that you'll see coming up. Because I won't be able to access the shoulder once the shoulder is in the fixture. So the inside and the outside of the fixture have to be concentric with each other, and the part has to be a close fit in the fixture in order for that to be valid. That's looking really good. You can see that's going to hold the part proud of the fixture and proud of the vice jaws a little bit, so that no matter what my upcoming setups, I've got room to get in there and access all of the material. Now I take the fixture plate over to the mill and put that same 3-hole pattern in it, this time clearance holes. Conveniently, this disc already had a big hole in the middle of it from something else. This disc was part of some other fixture, I think. It's got a bunch of random holes around the edges and all kinds of craziness. But I can use all 4 of those now to use the existing threaded holes on the smokebox plate and hold that tightly into the fixture. And that ain't going nowhere. One of my better investments was a grab bag of random indicator tips that I bought on eBay. It was a whole collection of weird ones, such as this benty pointery thing. These various weird shaped tips have gotten me out of all kinds of trouble, such as here when I need to dial in the fixture plate, but there isn't room between the jaws and the rough cut brass to get in there with any kind of regular tip. This weird bendy finger thing was perfect for that job. There was other ways I could have done that. You can indicate in between the jaws if you have to. It's just tedious because you got to pull the plunger in and out. Or in a pinch, I have also indicated on the backs of the jaws themselves. It's not great. That's obviously not as accurate. You're introducing a bunch of sources of error doing something like that. But yeah, like I say, in a pinch, it can be done. Anyway, I'm going to face that down. I'm going to face it down to thickness first because while it's still rough cut, I've got material sticking up above the fixture that I can measure it. So once I've got my final thickness, then I'll go ahead and turn down the OD. Obviously, this is a interrupted cut for a while until we get into round material all the way around, but it doesn't take too long. It's really worth spending the time on the bandsaw to cut close to your line before doing something like this, because if you think, oh, I'm turning it anyway, I just leave it square and I'll turn it round, it takes like 3 times as long to do that. That is a lot of interrupted turning time. It's much better to have as little work to do on the lathe as possible. The bandsaw is a lot faster. After a few years of hobby machining, one of the things you learn is that if you're trying to do things as quickly as possible, use the machine tools as little as possible. They are always the slowest part of any job. They are, of course, necessary and fun, but generally not fast. The next step then is to turn a large shoulder on the front of this. There's a little bit of a lip around where the actual door would be. It's the edge of what would be the door if the door was real, but of course we're making a dummy door in this situation. But I'm going to turn down a big shoulder. The bottom of that shoulder is the edge of what will be the door, and then the top section of that is going to be carved into a dome shape to form the shape of the door. That's tricky because we need to create a delicate and organic-looking compound curve. There's a small concave radius near the base of the dome, and then the dome itself is a large convex radius. This could be done freehand. You could etch-a-sketch it because it's not a functional shape. It just needs to look nice, and you could etch-a-sketch something that looks nice with your hand wheels. You could also freehand turn it with something like the Tornado turning tool. I considered that as well. If you have a ball turning tool, you could probably convince it to do this job in 2 steps. You could make or 3D print a template and then file to the template. That would probably also work, just like you would with a radius gauge. There's other ways, but what I decided to do is what's called step turning. And in fact, I've done a whole video on step turning. It's a very, frankly, easy way to get complex curved shapes like this on the lathe. So you draw out the profile you want. I used CAD in this case, but you could do it on graph paper too. You mark out a series of steps. That becomes your resolution, if you will, of your steps. And then you measure the distance from a baseline that's easy to reference on the part to that point on the curve at each step in your resolution. That gives you a series of shoulders to cut on the lathe. And after you've cut all of those shoulders, you will have an approximation of your shape. So bear with me here. I'm going to touch off on the X and Z to get my zeros. That's the baseline of my step turning diagram. And then I start turning those shoulders. I did the first couple of steps and realized something didn't look right. The scale of everything seemed off, like everything was just too small. And then I realized my DRO was set to diameter and not radius. Those numbers that you saw on my chart are all radius numbers. So luckily that error was in my favor. I just had to reset the DRO to radius and recut the first couple of steps. But then I can proceed to follow my little diagram. The first couple of steps are very deep, so I'm doing them by a series of facing cuts and then one turning cut to clean up the shoulder and make it nice. But then as I get closer to the top, the steps get very shallow and I can do them as a single facing cut. Now it's going to just sort of look like a hot mess here for a while, but you have to trust the process. Machine to your numbers and it will be an approximation of the shape, even though it doesn't really look like it yet to the human eye. That really is a compound curve consisting of a concave and convex shape all at once. It just looks like a Fresnel lens, but trust me, the shape is in there, and we are going to reveal it with the next step, which is a bunch of filing. I use a half-round file on the concave area and a flat file on the convex area, and all I'm doing is filing off the steps. You can see the corners formed by the step turning. All I'm trying to do is file those away. I'm not trying to create the shape or otherwise visualize anything or do anything artistic. All I'm doing is filing the areas where the steps are until the steps go away. And this is a very slow, controlled process, so you don't have to worry about going too far. you'll just see those lines gradually disappear and focus your filing on an area where the lines are more prominent. And once the lines are all gone, presto, like magic, your shape is there. After that, I used some 320 grit emery to remove the file marks. The goal is not to polish it because this is going to get painted anyway. I just want it to be smooth to the touch. And to be clear, this is not a high skill process. That might have looked like I magically created a compound curve with artistic filing. That is not at all what happened. This is a low skill process, which is why I like it. If you do the step turning to the numbers and then just file off the corners, that shape will appear, and it really does not require any skill to do this. If I hold the scale up now, you can see, like magic, I've got a nice convex dome at the top blending perfectly into a concave shoulder of smaller radius along the bottom. This is very accurate to the shape that is in the drawing, and it was no skill, really. Trust me, you can do this. It's a really great process for this kind of thing. While I'm working on the front, I can put a counter bore in the center there where part of those threads were. That's, again, for mounting the number plate on the front, and that's all we need from that setup. That was the trickiest part. Now we got a lot more details to make here though, so I'm going to take it out of the fixture and I'm going to show you something that I noticed when I was test fitting on the smokebox door earlier. And that is that it doesn't actually fit all the way down. You can see there's a gap there. And that's because I made an error on the mounting bosses for these. These guys here are supposed to be 3/16 recessed, and I recessed them 3/32. Whoops. I just had too many numbers flying around in my head that day, but not a huge deal. I set it up in the mill and I'll machine the excess off of the tops of them. They are very oversized in terms of depth, so it's not going to compromise anything strength-wise to machine a little bit off of there. I didn't want to get too close to the copper with the milling cutter, so I got as close as I dared and then finished up with a grinding wheel on the Dremel. And that is now a perfect fit. That is extremely satisfying. That pushes on there nicely, and that fits perfectly all the way around. Very, very nice. Now we're going to have to make the actual mounting points there, of course. And we got a bunch more holes in this thing as well that need to be there, so let's take it back over to the mill, set it up. I'll drill the mounting holes on either side, and then there's a bunch of hole patterns for mounting various accessories and things. So there's a 6-hole pattern that goes all the way around, and this is for the little clamps that hold the door closed, or would if the door was actually there. They are decorative as well, but we're going to put them in. And then I had to take a few tries on my DRO to figure out how to cut an arc of holes with a 6-degree lead in at both ends. And if you don't have a graphical DRO to do that trial and error with, you can also just put a Sharpie in your spindle and put a little dot, run through your hole pattern and make sure that everything is set up the way you think it is. The starting and ending angle options on DRO bolt circle features can be confusing. Sometimes they measure interior angles, sometimes it's exterior, sometimes they're counterclockwise angles. It's a whole thing. But anyway, those 3 holes are for mounting a handrail, and then I need to mill a couple of pockets for the dummy hinges that we're going to make. Since this is supposed to be a door, we need to make something that looks like hinges, and that is going to fit into those little pockets. I found some brass bar that's basically the correct thickness, and I'll make the hinge pieces out of this. I brought it to dimension on the shaper, and then a whole bunch of hand filing was done to round the ends so that they'll fit into those little pockets left by the end mill. The rounded ends look nice also, so it's sort of a nice happenstance that the end of the end mill makes a nice shape for the end of the hinges. Of course, on the real locomotive, the hinge bracketry and door are all one giant casting, so they all kind of have to look like they're all molded together, if that makes sense. But those are going to be the hinges, and then we need to make some little dummy pins as well. So the drawing calls for using screws for this, but I thought rivets might actually look better because having a giant screw head on the top of the hinge would be weird. There wouldn't be a giant screwdriver slot. On the real thing, this would probably be some kind of a forged pin or something, possibly forged in place, or it might be a giant bolt, but I can't make a hex head that small, so I'll use a rivet head, and I think it'll look pretty nice. And then the little downward part of the hinge, the bracket that would attach to the ring or to the frame of the smokebox, I made that with hand sawing and filing. And that all needs to get soldered together now, and then I'll file it to final shape after soldering. Soldering is a bit tricky though to hold all those pieces together in just the right place and just the right orientations, so I made this little fixture to do that. These are titanium strips that are used by jewelers for silver solder fixturing. and you can bend them into various shapes. In this case, I've bent it into kind of a double spring clip that holds the assembly together end to end and keeps everything in the right orientation while I solder it. These strips are titanium, as I said, and that's important because the titanium can take the heat, of course, but importantly, silver solder does not stick to titanium. So I can flood solder in there and it's going to run all over, it's going to run under the part, it's going to touch the fixture, but the fixture does not get soldered to the part. The flux goo will cause it to stick a little bit, but there's no solder that has touched that titanium. Now some mostly out of frame filing to create the rounded end and the slightly tapered shape that the hinge has. It's quality photography like this that lets you know I'm a professional YouTuber who's been doing this for 7 years. Yep, what a pro. Look at that framing. Just flawless. God, what am I doing with my life? Those dummy hinges are held onto the dummy door with a couple of small screws. It's not worth soldering them in place because soldering them would actually be really difficult because of the enormous mass difference between the two components. Once I've drilled those clearance holes, I'll use the drill in a pin vise to transfer the holes onto the hinges themselves. And then I drilled and tapped the hinges at those locations. And now we can attach them with some tiny screws. Well, that's starting to look like a smokebox door with some hinges on it, if I do say so myself. I think the rivets were a good call. Those look really nice. Now, next I got to get this thing mounted on the smokebox, so I'll blue up the bosses and I'll get everything level. I want the smokebox door to be straight, of course, with the boiler. These digital levels are great for that because you can zero them at any point that you want, so the entire thing doesn't have to be level. You just zero whatever you're trying to compare to. I'm eyeballing the mounting holes to get those level because I know those are perfectly straight across the smokebox because they were done on the mill in a single setup. I can also check squareness of the hinges, see if that seems about right. And once I'm happy, I'll transfer punch those holes onto the bosses. Then I took the smokebox off, over to the mill, drilled and tapped those positions, and now I can reassemble it all, and hopefully it all fits, and it's all straight and level, and puppies are playing in the street, and everyone gets chocolate. Well, holes all lined up, so I did something right, and it looks straight to my eye. At the end of the day, this is a decorative feature, really, so it just has to look straight. If it looks straight, it is straight, to quote Jimmy DiResta. However, this is somewhat functional as well. I mean, it is sort of keeping an air seal on the front of the smokebox so that the draft mechanisms of the blower and the exhaust steam can do their thing, but it doesn't have to be perfectly airtight. Let's get this back on the rails. This thing is getting very heavy, honestly. It's getting to where I might have trouble lifting it. It's quite shocking how heavy this little thing is. It's a lot of steel and brass in that. Well, there you go. Chugga, 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 chugga. Someday, little buddy, someday. That is a smokebox door. I'm very pleased with it. The step turning worked so well. I'm really glad I went with that option because the shape of it came out really nice. I couldn't be happier with that. I was a bit nervous about this. This is a complicated part in many ways, some tricky operations, and it was a big piece of brass that I only had one of, and it was going to be a $75 mistake if I didn't do it right. So I'm pleased it worked out. Thank you so much for watching. Thanks to my patrons for making all this happen, and I'll see you next time.